Okay, C means PowerPoint.
Ja, det kan vi.
Oh, okay. Okay, så om min dansk er meget bedre nu. Jeg tror, jeg skal tage det på engelsk, så forhåbentlig det er okay. So my name is Kurt, and I work at Septima with Mia, and I'm going to give a tour of the point cloud features in QGIS. And point cloud support was first introduced at QGIS 3.18, but with the latest long-term release that Mia just covered, there are many new point cloud features as well. So I'll begin with some frequently asked questions about point clouds. Yes. So first off, what are point clouds? Well, they're a collection of points in 3D space. They're typically acquired through LiDAR, laser scanning, or photogrammetry. And of course, you can collect point clouds with drones as well. The points in a point cloud dataset are not uniformly distributed. Their density varies due to surface properties, as we'll see in some of the datasets that I show you. And they have attributes, just like a vector layer. So they have attributes including X, Y, and Z coordinates for each point. So what can you use point clouds for? Well, first, QGIS has a variety of rendering options for visualizing point cloud data. So there's a classification renderer so that you can see different types of objects in the point cloud. For example, one color for buildings, one color for trees, one color for bare ground, and so on. There's also, you can also render the point cloud data by numeric attributes, just like you can with vector and raster layers. So for example, you could render the point cloud with a color ramp based on the elevation or Z values of each point. The 3D viewer in QGIS supports point cloud, so you can make 3D scenes and fly-throughs with point cloud data. And the new elevation profile panel supports point clouds, and I'll give you a short demo of that in a few minutes. So you can make elevation profile plots with point cloud data, which can be quite beautiful. And then in terms of analysis, you can make measurements with points. So you can use the measure tool and snap to individual points and measure heights of buildings, distances between trees, and so on. You can also filter out specific objects. So for example, you could filter the point cloud to show just the trees or just the buildings in a data set. And you can actually then save those as new point cloud data sets. And you can convert point clouds to both raster and vector data if that's important to your workflow. So what types of files are used with point clouds? Well, there are two main formats, LAS and LAZ. And LAS is an open binary format that includes attributes, as I mentioned, the X, Y, and Z coordinates, intensity, color, classification are common attributes with many point cloud data sets. And then LAZ is simply a compressed LAS file. And when you add one of these LAS or LAZ files to QGIS, QGIS will create an indexed version of that as either an EPT or a COPC file. So EPT is the older, what we call background format for point clouds in QGIS. The current long-term release that Mia just presented on, 3.3.4, uses COPC, which is a cloud optimized point cloud. So when you bring in an LAZ file into QGIS now in 3.3.4, it's going to index it and create this COPC file. And that just happens the very first time you add that. So where can you get point cloud data? Well, Data Fasooning has nationwide coverage of point clouds. And of course, as I mentioned, you can collect your own with drones. On the Data Fasooning site, you can either browse the map and download data in 10-kilometer blocks, or you can use the FTP link and look for specific tiles. So for example, here I am on Data Fasooning, and I'm going to choose the 10 by 10 kilometer block option, and you can then zoom and pan around the map. I'm going to try to find a collection in central Copenhagen. And so I see the 10-kilometer grid. I'll select the one for Copenhagen, order this collection, and then download it. This one is 18 gigabytes, so it's quite a large download. If you want a smaller download for specific tiles, the FTP option is probably better. And once I have downloaded those, I can add them to QGIS just as I would with vector or raster layer. So I'm using the browser panel to add these 9 point cloud files to QGIS. And again, when you first add it, it shows as this red dashed line extent only view of the data. And as soon as QGIS has generated the cloud optimized point cloud file, it then shows the classified rendering. And so this, you can see as it's generating these for each of these 9 tiles, it switches to that classified rendering. And again, this happens just the first time. So the second time I add these to a QGIS project or open this QGIS project again, it will be very fast. The new long-term release that Mia covered also includes a set of 17 native point cloud processing tools. These were introduced at 3.3.2 Lima. And you can see there's tools for point cloud conversion, for vector and raster, point cloud data management, and point cloud extraction. So I'll show a small example of a tool from each one of these categories. For example, merge is a processing tool which allows you to merge or mosaic multiple point cloud files into a single file, just like you might do with raster data sets. Yeah. So it includes some advanced parameters. There's the filter expression, which you can use an expression to mosaic just certain pieces of the selected point clouds. And it includes the cropping extent. So you can mosaic and crop at the same time to the current map extent if you so choose. So here's an example with the 9 point clouds I downloaded for central Copenhagen here. I'm going to run the merge point cloud tool. So I'm going to zoom into Rosenborg slot, Kongenseo, and find the merge tool. I'm going to tell QGIS what the input layers are. I'm going to select all 9 point cloud files. I'm not going to use a filter expression, but I'm going to set the cropping extent to my current map canvas. And then I'll save this to a file. I'll just call it Rosenborg. This will be an LAZ file. Click run, and QGIS will execute this tool. And since this is a new LAZ file, QGIS will again have to index this the first time. So it shows up as extent only, and afterwards we'll see the classified rendering of that. So I simultaneously was able to merge a bunch of QGIS files together and clip them to the current map extent with that. Another useful new feature in the long-term release is a new data provider called Virtual Point Clouds, VPC. So this is a similar concept that you see with virtual rasters. Point cloud files are large, and they typically are delivered as tiles. So virtual point clouds allow you to essentially merge a set of tiled point cloud files into a single layer but you're only creating a small JSON file instead of a new LAZ file. So it's a JSON file with a VPC extension. And it's basically a pointer to a set of LAZ, LAS, COPC files on your computer. And the result is a virtual merged point cloud layer that you can use just as you would with the result of the merge tool I ran. So this is sometimes a better option when you're dealing with a huge quantity of point cloud tiles. You can create a virtual point cloud for them, which would allow you to run processing tools on that virtual point cloud. And you can also, view it in the 3D environment and treat it basically as any other single point cloud layer. So there's two options for managing multiple tiles. You can either physically merge them into a new point cloud file, or you can create a virtual point cloud and work with that. Here's an example of that virtual point cloud tool. It's very simple. It just asks for the input layers. So if I was going to run it on that data I downloaded, I would have the 9 inputs. You can set some arguments such as calculate boundary polygons, statistics, build an overview point cloud, and then just name the output VPC file. And it's very quick to run. So I'm going to get out of my presentation and show you a demo in QGIS of how to style point clouds. So here I have QGIS open. This is the long-term release, and I have a point cloud that I filtered out around Rosenbois slot and Condenseo. And I'm showing now the extent only option. But in the layer styling panel, I can see there's many options for rendering this point cloud. I can choose classification, and here it will divide this into categories by the classification attribute. So we see categories such as low, medium, and high vegetation, buildings, water, etc. And off to the right, QGIS calculates the percentage of each of these categories. So I can see that most of this data set includes ground, points, high vegetation, and buildings. Below that, you can see that there's options for setting the point size and style. So the default is a square point, 1 millimeter square, but I can change the size of the points if I want to make them bigger or smaller. And I can also change the style from a square to a circle or a point for those. I'll set it back to the default here. Below, there's some layer rendering options, and there's a draw order here. So I can choose to render these bottom to top, and so this will filter the way they're rendered by the Z values. So if I render this as bottom to top, I'll get a very different view. So now you're going to see the highest points of the trees drawn last, so they're on top. If I choose top to bottom, we'll see more bare ground, and the points for the trees will be below that, so it will look quite different than that. So you can choose to render this with any of these settings depending on what your needs are, and you notice that there's also opacity and blending mode controls for point clouds. Another option we have besides classification is attribute by ramp. So here I can choose a color ramp and any one of the attributes and render the data via that attribute. So for example, I could render it by the Z attributes. So this will give me a rendering of height. This is much slower than it was before the presentation, so sorry about that. Okay, so now we're seeing elevation rendering. So we're the trees and the rooftops become very clear. You can also choose number of returns. So the trees, for example, typically have many more returns or more complex structures than a flat building surface. And so often when you choose number of returns, you will see things like trees have the highest number of returns. And so rendering via these ramps is one way you can explore your data and see what some of these attributes contain visually. Another thing you can do is RGB, red, blue, and green. So this data set from Data for Suning didn't include RGB. I ran a third-party plugin called Last Tools to create this, which I'll show you. But this gives you a true real-life rendering of the data because it's using the orthophoto for the color of each point. This was run from, there's a plugin called LAS Tools, which I'll talk about on the next slide. And there's a last color tool that you can use to create this. This is the free version of the plugin. And if I go back, I'm going to show you one more thing. If I go back to the classification, and I'll set this to the default rendering, there is a tab in the layer styling panel called Shaded Renderer. And here I can turn on iDome lighting, and this will give some texture to the points. So things like trees and buildings start to appear more like discrete objects. And you can also try hill shading. So there's quite a few rendering tools in QGIS for point clouds that give you different options to view your data. Go back to my PowerPoint. This is that LAS Tools plugin that I use to give a true color rendering of my points. So I use the LAS color tool, and it takes the point cloud data set, and then you have to give it an input orthophoto. So I basically exported my map canvas from the latest orthophoto from Data for Suning to an ortho TIFF and use that as the input. And then QGIS will output a new LAS file that has those RGB attributes that you can use to display that data. So it's also possible to use the elevation profile tool with point clouds. So here I'm going to zoom in a little bit, and I'm using the RGB rendering of the data. And the elevation profile allows you to draw a line across your data set. So I'm drawing a single line. And so with the default setting, you're getting a 1 point wide rendering, but you can increase the tolerance here to get a wider swath of points. And at a certain point, it becomes almost a true life 3D view of your data. You can then use the measure tool on the elevation profile panel to measure heights of buildings, for example, or heights of trees, distances between rooftops and things like that. The tool will snap to individual points. You can also use the identify information button, and it links to the map canvas as you click on features on the map. So you'll see them highlight on the map canvas. So the identify tool works the same with point cloud data as it does with vector and raster data. So layer properties with point clouds has some different features. To start, you do have the same general information on the source of the file, the coordinate reference system, the extent. But here you also have a section where it will list all of the attributes in your data set. So it'll also give you the type, whether they're integer, string, text, and et cetera. So you can see what your data set includes. And there's then a statistics tab, and you can use this to get more information about your data set. So for all the numeric fields, it will give you the minimum, mean, and max and standard deviation values. So you can understand the data a little bit better. And then down below, the classification statistics. So you'll see the number of points in each category, and then the overall percentage that each category is in the data set. So once you've seen that, you understand your data a little bit more, and then you may want to filter the data. And filtering is basically using, it's like selecting by attribute, where you can create an expression and create a copy of the data with just those selected points. So here I'm using the Rosenboa LAZ file, and for my filter expression, I'm going to choose just the trees. So classification equals 3, 4, or 5. So that's low vegetation, medium vegetation, or high vegetation. So there's now an expression engine in QGIS for point clouds that allows you to select points based on the attributes. So you build the expression the same way you would with a vector layer. And then the output is going to be a new LAZ file. Here's another example where I'm going to select out just the buildings. Buildings are category 6, building, so classification equals 6. And this is going to be just the buildings for Rosenbowl. So here's the result of that, where I have just the point cloud data set that consists of buildings. It comes with all the same attributes as the original, so I can still style this with RGB values. So you can filter out a data set that includes just trees or just buildings or any one of the attributes. You can also filter by elevation. So maybe you want points that are just above a certain height. Any of those attributes you can use to do specific filtering exercises. Once you've done that, you can also interpolate or save point cloud data to a different format, such as vector or raster. So I have my building point cloud layer, and in the point cloud conversion toolbox, I can convert the format from LAZ to LAS. I can export to a raster or export to a vector. So here I'm going to export my building point cloud to a raster, and the attribute I'm going to use is the Z values. So this will be a DEM. Set the resolution to 40 centimeters and give this an output file name. So this would simply be called Rosenbowl or Buchninge TIFF. So I'll basically have a DEM or a digital surface model of the buildings when this is done as a GeoTIFF. So at that point, I can render this with any of the same tools I would use for a DEM. So I can choose the Hillshade renderer and get a rendering of my buildings. I'm going to set some resampling options so it looks a little nicer. You can use blending modes if you wish to blend with the true color below. And then I can begin to explore my data set a little bit. You can zoom in and inspect some of the buildings and see how the data look. And we've created now a raster of buildings from the point cloud. The point clouds can also be viewed via the 3D viewer. So this is a point cloud mosaic of the Viking ring fortress Trelleborg. And in this example, I'll be using a couple settings that are new for point clouds in the long-term release: show shadows and ambient occlusion, which you'll see when this plays that it gives a nice look to the trees. So I'll click play on this. So this was a video that was created from the 3D viewer in QGIS. So you can create some very nice visuals in the 3D environment. And lastly, there's a feature added at the latest release of QGIS 336 Maidenhead, the latest stable release. And this allows you to render the point cloud as a surface in the 2D map canvas. So this can create some really nice results, especially when you're using one of the attribute by ramp renderings. So you can see before I use this, there's small gaps in the point cloud. And as soon as I render it as a surface, it becomes much more detailed and all the gaps are filled in. It uses an on-the-fly Delaunay triangulation of the points and creates triangles instead of individual points to render the data. So that's a short tour of some of the things you can do with point clouds in QGIS. I think with this current long-term release, we're getting to have a pretty full set of tools to be able to not only just view, but analyze point cloud data in QGIS. It's quite nice. And I have one more slide, a shameless plug. I have a new online course. It's going to be in April, week 22, working with point cloud data in QGIS. This will be a 3-hour online course with a 1-hour follow-up session. En Salam Kosel Fogo på engelsk kan je til dansk. Så du skal ikke bekymre dig om sprog. Det vil være fint. Så jeg håber at se nogen af jer der.
Tak for det, Kurt. Super spændende. Spørgsmål, ja. Der er ikke nogen i chatten, så vidt jeg kan se. Har du opsnappet nogen undervejs, Bo?
Nej, det har jeg ikke. Men nu kom der, Lene har lige skrevet ind. Is it possible to filter out outliers as seagulls and moles from a point cloud data?
Yes, of course you can do that. You probably have to identify the elevation and XYZ coordinates of those to select them, but of course it's possible. In fact, if anyone noticed in that Trelleborg video, I think there's a point floating above that must have been a bird or something when the data was captured.
Okay. There was another new question here. I'll try to translate it into English. A 3D demo of Trelleborg. Can you add, example, a new building or projected building? And if you can, how to do it?
Yeah, so maybe well if you have if it's like a building that doesn't exist yet, you could certainly build that as a new vector layer and extrude that into 3D space. So combine some vector data with your point cloud to render that scenario in the 3D viewer. So that would certainly be possible to do. If it's a building, or you may need to have, if it's a new building that isn't included in the current point cloud, you may have to get some drone imagery to create a new point cloud from that and add that to this current one. So depending on the situation, but yes, it should be possible to do that.
Another one, me says it's amazing with all these new features, and I concur with her about that. The next question is it possible to make a surface from the points and export it as a DXF or DWG file?
No. Well, I guess there might be a couple of steps. You could export it out to a vector layer, and then maybe you could export that out as a DXF file with the tools that QGIS already has for doing that.
Yeah.
But there's no direct point cloud to DXF. And
you showed how to make a surface, a raster TIFF surface raster. Yeah. And that you could actually use that to polygonize that layer, yep, and get vectors from that.
Absolutely.
Yeah.
And there's
Great.
also export to vector in the toolbox. So
Okay.
point cloud to vector directly.
Okay, thanks a lot, Kurt.
Yep.
I think we have to move on. Can you give Henrik Larsen the host role? And he will take over from here.
Yes.